students. Today we will continue solving practice 3.5 of 10th standard maths part 2nd geometry. In that chapter 3 circle. Okay. Now third one is in this figure O is the center of the circle and B is a point of contact. Segment OE is perpendicular to segment AD. AB is 12. Okay. AB is 12. AC is 8. Find AD. We have to find AD, DC and DE. Okay. So you can see here a circle with center O and line AB, like this ray AB is a tangent to a circle at point B. B is a point of contact and here is a secant. AD is a secant. It intersects circle at point D and C. No? Which theorem we have to use in this? This is a tangent and this is a secant. So we have to use tangent secant segment theorem. No? Yeah. For that, first we'll write. Here in this we'll write ray AB is a tangent to a circle at point B. Okay, and line AD intersects circle. AD is a secant, intersects circle at D and C. Therefore by tangent secant segments theorem. What is the formula? Tangent secant segments theorem. So we have to, this is the name of this theorem. So we have to start in the tangent. That is what is the formula here? Tangent, that is AB square equal to AC into AD. No? AC into AD. This is the formula. No? So for that, by theorem, AB square equal to AC into AD. Now substitute the values. AB is 12 square, therefore 12 square equal to AC. AC is 8 into AD. AD that we have to find out. Therefore AD is 12 square, that is 12 into 12 divided by 8. So 4 2s are 8, 4 3s are 12, 2 1s are 2 6s are. Therefore AD is 6 3s are 18. AD is 18. We have to find out AD. AD is 18. Now we have to find DC. DC, here AC is given here. See here, this AC is 8. We have to find DC. AD we know the value of measurement of AD we know. Therefore AD is, we have to write here, AD is DC plus AC. No? AC plus AD is AC plus DC. AD is 18, therefore AD is 18, this 18 equal to AC is given here 8, AC is 8 plus DC that we have to find out. Therefore DC is 18 minus 8, that is 10. DC is 10. Now we have to find out DE. In this, DEC. Here it is, O is the center of the circle and a perpendicular drawn from the center of the circle to its chord. DC is the chord here. Okay, this OC is drawn perpendicular drawn from the center of the circle to its chord, bisects the chord. It divides, this perpendicular line divides chord DC into two equal parts. DC we know, DC is 10, therefore DC here to here, this length is 10, this DC is 10, then D is half of DC, no? Okay. Therefore, we'll write here perpendicular drawn from the center to its chord. Okay. Perpendicular drawn from the center to its chord, bisects the chord. Therefore O is perpendicular to chord DC. Therefore segment OE is perpendicular to chord DC. O is perpendicular to DC. Therefore, now we have to find out DE. Here it is DE. DE is half of DC. That bisects the chord. DE is half of DC. Therefore, half into DC is 10. Therefore, DE is 5. Okay, DE is 5. Therefore, write the answer. Answer is, one is AD. First one is AD is 18. Okay. Then second one is DC. DC is 10. And third one is DE. DE is 5. Okay. Fourth one is, in this figure, PQ is 6, QR is 10, PS is 8, find TS. Here PQ is 6, QR is 10, PS is 8, find TS. That we have to find out. Okay. So for this, see here in this is a circle. See, we can see two chords, TS, ST and QR. These two chords, no? These two chords, they intersect outside the circle at point P. No? Therefore, which theorem you have to use? We have to use theorem of external division of chords. No? We have to use external division of chords. How to write the formula? So we have to start from the external point, that is PS into PT equal to PQ into PR. No? This is the formula we have to use. For this, PS is given 8, PT, that we have to find out. Okay. Then PQ is 6, and PR means we have to add RQ plus Q. PR means what? PR is RQ plus PQ plus RQ. No? PR. That we have to find out first. Therefore, PR is PQ plus RQ. That is PQ is 6 plus 6 plus RQ is 10. Therefore, PR is 16. Okay. Now, we'll write chord ST, chord ST and chord QR. Chord ST and chord QR are intersecting outside the circle, at point P. Okay, therefore by external division of chords, we know the formula, that is, from here you have to start, PS into PT equal to PQ into PR. See, this theorem says, see, this is external division of chords. External, you have to start from here. This point only you have to start. PS into PT, PQ into PR. Okay, therefore PS, here PS is 8, PT we don't know, equal to PQ is 6 into PR is 16. Therefore PT is 6 into 16 by 8. 8 ones are 8 twos are. Therefore PT is 12. No, PT is not necessary to put in this way. PT is 12. Now PT, see, PT is 12. They ask TS. TS we have to find out. What is PT? PT is PS plus ST, no? So therefore PT is PS plus ST. PT is 12 equal to PS is 8 in plus ST or TS. TS I wrote because they asked find TS. Therefore TS is 12 minus 4. Therefore TS is 12 minus 4. 12 minus 8. 12 minus 8, answer is 4. TS is 4. Therefore answer is TS is 4. Okay, this is the answer. Fifth one is, in figure, segment EF is a diameter, okay, and segment DF is a tangent segment. The radius of the circle is R, okay, R. This is 1R and this is R. This is the diameter, so this is one radius and this is one radius. Prove that DE into GE equal to 4R square. Okay. So what is given here? Given is segment EF is a diameter and segment DF is a tangent to a circle. So here is a DF is a line DF is a tangent to a circle with center H. Okay, and tangent touches the circle at point F. F is the point of contact. Okay, and line DE is a secant intersecting the circle at point G and E. Okay, so therefore which theorem we have to use? Tangent secant segments theorem. According to that theorem, what is the formula? Formula is tangent. Name of the theorem is tangent secant segment theorem. Therefore tangent is df square. This is the formula, df square equal to dg into de. Okay, this formula we have to use. We'll write here proof. For this you can write given, also you can write given to prove that, then proof, like that also you can start. Given is segment EF is a diameter, okay, line Okay, we will write segment EF is a diameter. Okay, diameter, and segment segment DF, segment DF or lines DF is a tangent to a circle at point F. DF is a tangent to a circle at point at F. And DE is a secant intersects the circle at G and E. Therefore, by tangent secant segments theorem. So, therefore, tangents is df square. Therefore, df square equal to dg into de. Okay. Now we have to take this triangle DFE. This triangle, angle DFE is a 90 degree. How we can say this DF is a 90 degree? Because tangent theorem says, no? Because of tangent theorem says angle DFE is a 90 degree. When this is 90 degree, this is angle F is a 90 degree, we can use Pythagoras theorem. No, we have to bring this, we have to prove. Okay, Pythagoras, according to the Pythagoras theorem, hypotenuse square equal to the sum of the squares of the remaining two adjacent sides. Okay, therefore, in triangle DFE, angle DFE is 90 degree. Therefore, by Pythagoras theorem, hypotenuse square DE square equal to DF square plus EF square, EF square. Now in this, what is EF? See, we have to simplify. We have to substitute now. What is EF? See, EF is the diameter of the circle. What is a circle? What is diameter? Diameter is twice the radius. No, twice the radius. So we have to write, therefore, DE square equal to DF square plus EF. EF is, see, diameter is twice the radius, 2 times radius. One radius is this is radius and another radius, that makes one diameter, so twice the radius. Therefore, EF is twice the radius. No, this is a diameter. Therefore, 2r square. That is DE square equal to DF square plus 4r square. 2 to the 4, 4r square. So now what is DF? DF is this formula where DF is DG into DE. Okay. Therefore, we'll write first, bring 4r square here. Now, DE square minus DF square. So, this 4r square, bring it to the left hand side. Then write this DE square minus DF square. Okay. Now, this is DE square as it is. What is DF square? Here it is. See, DF square Okay, instead of df square we have to write this dg into de. Okay, this is 4r square. Therefore 4r square is, in this we can keep de here. This is one term and this is one term, so this is de square, here it is d square, we can keep de out. Therefore 1 d is remain here in this, minus d is out, dg. Okay, therefore 4r square is de into de minus dg. See here in this de minus dg, see de, see here de full minus dg. What is remain here? Ge, no, ge, that is into ge. Therefore de into ge is 4r square. That is de into, see this is de into ge equal to 4r square. Okay, so this practice set 3.5 has got over. Okay, so in my next video problem set will start. I'm going to start problem set 3. Okay, so if you have any doubt or any suggestions or anything, do let me know in the comment section. Okay, if you're watching my video for the first time, please subscribe to my channel and also like and share. Okay, then bye.